Alright, so we might as well dive in. And I apologize for you guys. Yesterday I had some issues with what I posted versus what you guys had. So the first thing I wanted to make sure that we talked about is volumes of pyramids. So if somebody were to try to summarize, I have a ton of papers to hand you guys back, so we should have plenty of time at the end of class to do that. But please make sure I do that before you guys get out of here. Someone was going to summarize how the volume of pyramids was different than the volume of prisms. And I forget which video I had you guys watch, but did you guys watch the one where I actually showed it to the cameras and with the water and everything? Okay, so Ozzy, what do you think?
So it's just you make a square, like a cube, out of what you like the triangle.
No, it doesn't necessarily have to be a cube.
Well, just multiply the length, the width, and the height, then
So if it's got length, width, and height, what kind of shape is that?
It can go into any type of prism.
If it's not a prism. So be careful saying cube. So we're relating our pyramids with their similar prisms. Okay, so what else?
Alright, and then after you multiply the length, the width, and the height, you also multiply that by 1/3.
Yeah. So the amount of volume that is chopped off by, instead of bringing it up to the same shape, instead bringing it up to a single vertex into a pyramid, that creates a relationship of 1/3 of what the prism volume would be. Any issues with any of this pyramid volume stuff that you guys did in the blended format? Elena?
I never got 15.4 because I didn't get to start it.
So if they disappear from over here, they're probably over here, which actually that stack is up here now. So you just gotta kind of stick with my system if you can wrap your head around it. Do you have 13.5? Does anyone else need 13.5? Just 5? Hold the stack.
Mr. Hudson, are you sick?
Yes.
He's been out a bunch of days.
Raise your hand if you need 13.5. My doctor nicknamed what I had the kitty crud. But he said the fact that I work with middle schoolers and my wife works with elementary schoolers and that neither of us have the flu or the neurovirus, he said that we're lucky. And I said, I'm glad that you're an optimist. Mm-hmm.
What's a neurovirus?
Really, really bad. You do not want it.
Is it like for your brain or something?
Huh?
Yeah, how come you don't get sick that
Neurovirus is
I thought you were talking about cats, like a kitty virus.
No, like
Like a kitty.
kids. So the thing that I'm fighting against, those go in that back rack actually, thank you. The thing that I'm fighting against is that my wife brings home all the germs from her students. That hanging,
Oh,
the thing that if it was a snake would have bit you. Any issues with this? Any issues with the 13.4? The video is posted, I think it goes over pretty well. If you know how to do prisms, you know how to do this, because all you have to do is then divide by 3. Anish? So if you choose to use it, that's one of those whole, like, if you don't want to keep math in your binder section, well, it depends. So you can have a separate math binder, which is what you're going to need in 8th grade, or you can just have your notes clipped in this binder and everything else you do in a separate math notebook, which if you're good and organized, you should keep all your math work together. I kind of gave up on that fight, and I should fight harder about that, but a lot of you guys just do it on a sheet of paper and then you like recycle it or whatever. That's not really great because then you can't go back and look at what work you did. Nothing from 13.4, because I know we got questions on 13.5. Sam, was that a question on 13.4?
No.
So, moving on to 13.5, we then, have some shapes that we haven't dealt with here. So, this is taking our knowledge and extending it beyond what we know. But if I were to relate a cylinder with any shapes that we do know, what sort of figure, like 3D shape, could we relate a cylinder to? Andrew? Yeah, what 3D shapes that we've already dealt with, that we already know? That's not 3D. Square's 2D, do you remember? Yeah, so a prism has what characteristics? Momsy?
The base goes
the base shape is cloned or stretched all the way to the top, and they're connected. Straight edges that are rectangles. What do you think would happen if I took a can of soda and cut off the top and the bottom? And some of you may have done this already. Cut off the top and bottom and look only at the edge around it. So I take my can of soda, cut off the top, cut off the bottom. We don't care about the top and bottom. It's just a rectangle. Same thing as our prisms, where we had every rectangle for every face, and then when you combine them together, you get a bunch of rectangles. Well, this does a pretty good job of showing it. Imagine, what if every degree of the circle, if you imagine that that was a straight edge, so this is a 360-sided shape. Just imagine with me for a moment. So a 360 gone. And every edge was a rectangle from the bottom up to the top. This kind of helps you visualize what that would look like, but as I lay them all out together, it's one big rectangle. So again, surface area of a cylinder is just 2 times your big B plus your lateral area. Now, how do you think we would calculate the lateral area? I've been here for a couple days. This thing might be dumb. Smart Ink is turning off. Why? How do you think we calculate that lateral area? Huh?
Since it's just a really big rectangle, what we have to do is we can just do length times width.
Now, how do I
And
get
to
that
get
length?
those length times width in this cylinder, it would be the height times the circumference.
Yeah, it'd be my
of the
height
circle.
times my circumference. There we go. Should have Smart Ink back now. So, here, to find surface area, all we still do is 2 times your big B plus your lateral area. It's the same exact formula, except lateral area now, wherever you want to write this, is going to be the circumference times the height. So that perimeter that we used before, that's just circumference now. That perimeter that we used before is just circumference. Now, this is where it actually gets real interesting. When we make a cone instead, I forget if I have a cone. I have pyramids. I do have a cone. Up here on your start slide, you can kind of see this. Cone base is easy to talk about, right? It's a circle. Whole circle, pi r squared, we get that. But this part, ignore the bottom circle. The part that we have left over, the lateral face, shown up there as a blue sector. A sector is when you take a part of the area of the circle, but not the whole thing. So this is a sector because I'm missing a chunk of my circle. Now notice, that chunk missing looks like an acute chunk, or sorry, an obtuse chunk. This chunk missing is bigger than 180 degrees. But regardless of the size of the chunk that's missing, the lateral area here, like it shows up on our start slide, is just pi times r times s. And that s is just the slant height of the cone. We're going to do a chapter where we specifically focus on these things. Round three-dimensional objects. This is just to give you a taste of it.
Lateral area.
Now, spheres is where things get real interesting. And, oh, by the way, sorry, volume here works the same exact way as a pyramid. So 1/3 base area times your height. If you know what your height is, sorry, that would have to go to the vertex. If you know what your height is, it's the same as a pyramid. 1/3 big B times height. Same as a pyramid.
Why do we get pi there?
So we'll still use pi in my volume formula, because to find big B, we got to use pi.
Uh-huh.
Anything that's round has to use pi.
Yeah, but why do we use it in the lateral?
We use it in both. Whether we're doing volume or area or anything, it's circular. We have to use pi. So this section right here, this is not included in your lateral area, right? Because that's included in surface area. But lateral means side, like all the way around the side of it. So this is our lateral area. It's part of a circle. So instead of calculating the whole pi times radius squared, which it would be if it was a whole circle, we do pi times radius times s, because this right here, instead of radius times radius, it's my radius, distance from the middle out, times the slant height of the object, which is this. Because it's only part of the circle. Like we're gonna take a chapter where we dig deep into these. I'm just showing these because this lesson relates them in. Pulls them because it's exactly the same as a pyramid. We just use a different method because it's round instead of rectangles or triangles or any other shapes that are easy to work with. We have round shapes now, parts of circles, we gotta use pi. Anytime we have anything round, we have to involve pi because it's that ratio, it's that relationship. And the sphere, we'll get to that. You don't need to know too much about that, and that won't be on the mastery for this chapter. Ellie.
Wasn't the slant height L, or does it?
Yeah, it has lots of different names. So we either use cursive L, like that, or we can use S for slant height, whatever you want. The problem with L is just then people confuse it with other lengths. But if you can keep it straight, that's fine. Sometimes people just like S for slant height. So, knowing this,
Couldn't slant height also be the radius in this?
so that would be the radius of the partial circle.
Yeah.
The R that it talks about is the radius of the base.
Oh.
So, because we don't have a full circle here, that slant height, and that's why it uses both of those. Because instead of radius squared, it's not a whole circle where the radius is the same all the way around. It's a circle that is only as big as the base is. So this circle is only as big as this circle allows it to be. That's why this circle's radius and this circle's radius get multiplied together,
And pi is there
because it's a circle. We have to use that ratio because it's a circle. Let's clear this really quick and check out this problem. So, we're at a birthday party and we get bored, right? We've got those birthday hats that everyone always has, and they're cones. So everyone's walking around with birthday hats, and we decide, what could we make if we took two of these hats and put them together? So we did. We find some hot glue or some duct tape or something. We put these two hats together. Then we decide we want to cover it. Make it into a weapon or something. We're going to use our imagination, right? So if you grab it in the middle, you could kind of throw it or something like that. So we decided we want to cover it with paper. If we know that the base radius is 2 inches and that both of these shapes are identical, how much paper will need to cover both of them? Now, are we going to need to cover this part of the cone? No, and actually that part of the cone doesn't exist because it's a party hat. So all we need to do is figure out the lateral area
times 2.
and then multiply it by 2. Have at this for a second. I'm going to reorient my board.
So does like the distance across the bottom of the hat equal to?
What's your question?
Like does that mean like the bottom of the hat is 2?
No, that's the base radius. So the bottom of the hat all the way across would be 4. Because if the base radius is 2. So what we're setting up here, we need to get familiar with our formula. That lateral area. And I can use slant height here if we want. Here's the trouble, though. Do I know my slant height? Now, if I start identifying what I do know, this 10 inches here is probably important.
That's the height. That's the height.
So, if I look at this, I can figure out that's 5 inches.
Yeah.
And the problem already told me that that's 2 inches.
So wait, could you? It's a triangle, so.
I'm waiting to see a hand. I have lots of people just kind of thinking out loud. Oh, Anish, what's up? What we're looking for here is actually the hypotenuse of a right triangle. So, unfortunately, I was sick today, or sick yesterday. But my point with this lesson is to push us into understanding why are we going to need the knowledge in the next couple chapters. So, as we get through these next few chapters, we're going to be going beyond 7th grade content. We're going to be getting up into this 8th grade stuff. And that's because to solve some of these higher order problems, we got to be able to solve for parts that are not given to us. So if I don't know this length, what's one thing that I do know about that? I don't need number knowledge, but just talking about if I can kind of make some guesses before I start working. Honestly?
It's equal to the square of.
Okay, you're getting way too mathy. I just want some observations. We'll get there. What you're going to say, I'm sure, was probably right. But you're way too deep. Sam? Okay, it's a right triangle. That means I can use the Pythagorean. Moon?
Does the slant angle have to be more than 7?
The third side of this triangle, which is one of the most commonly missed questions from our mastery about 2 and 3D shapes. Can this be equal to 7? No, because then my triangle would be a flat line, because 2 plus 5 equals 7. As soon as I raise my 2 and my 5 up, the distance between them, actually, what could the distance between them be? So think about this not right triangle. What if, because I'm taking a moment about this because a lot of you missed this on the test, if I have 5 and 2, this side I know has to be greater than 3. But if I set up 5, this is not to scale, and 2, as soon as I lift up my 5 and 2, my 5 and 2 can't change, but what happens to the endpoints as I lift them up? They get closer and closer, so this tells me this has to be less than 7. So my range here is 3 to 7, but I know it can't be 3, because it would be a flat line, and it can't be 7. A lot of you on your test made statements like 3 is less than or equal to x is less than or equal to 7. They can't be equal. Those equals cannot be there. So already, we know it has to be longer. The hypotenuse has to be the longest side. So it's got to be bigger than 5.
It's either 4, 5, or 6.
It can't be 4. It's got to be bigger than 5. The hypotenuse has to be the longest side. So it's going to be bigger than 5, but we don't know that it's an integer. We don't know that it's an integer. And it's, quite frankly, probably not going to be. So now, without a bunch of guess check work, we can use our magical Pythagorean formula. So, Manasa, what you were trying to get to.
Okay, so we know that the hypotenuse squared is going to be equal to 5 squared plus 2 squared. And that's 29. 29.
Genius.
So we need to find the square root of 29.
And this is where a lot of us get stuck, because we haven't done Pythagorean theorem yet. I get it. I'm not going to ask you to do this on the mastery. We're just intro. We're slowly working into it. When you have something squared, To undo that, we do the inverse operation. Inverse of multiplication is division. Inverse of addition is subtraction. Inverse of powers is roots, or our roots. I don't quite know how the grammar works out with that. So since we have the square power, we use the square root, which does not need any number over here. If it was cube root or fourth root or a higher root, we would put a number inside that little check. But when we square root, we're just saying there is some number that when multiplied by itself will equal 29. 5 times itself is 25. 6 times itself is 36. It's between there. Now, there's actually a really nice method called the Rachel method, where we nicknamed it because of a student a couple years ago. Rachel Shaw, in case you know her, but she thought up this really clear method, and there's lots of methods from a long time, to approximate perfect squares. If it was 5, that would go to 25, right? 5 squared is 25. If my answer was 6, this would have to be 36. But it's not, right? I have 29. Is my 29 closer to 25 or 36? So we think to ourselves, how far away is this? Well, it's 4 above, or it's 7 below. So I'm going to go to the closer one and say, all right, I'm at 5 and 4 out of, what's the total gap between your perfect squares? 11. So what if we try for this 5 and 4 out of 11? Somebody calculate what 4 divided by 11 is. Somebody with a calculator. Somebody else calculate square root of 29. To do square root on your calculator, you hit second and then the square button right beside the 7. Second and then the square button does square root. So we get that C rounded. That's what square root of 29 gets you. But if I do 4/11ths, if I did 5 and 4/11ths, my green over here, that would give me 5.363. Look at how close I am. I'm 2/100ths away from the perfect square root, or like very out to that place value. It's perfect. We approximate eventually. We round eventually. We'll do more with this as we get into our chapter dealing with the Pythagorean theorem. It's really the blue. This is really the C value because we did the square root. But if you did not have a calculator, because remember, our division by 11 multiplies by 9, so this would be 3636 forever. And when I actually do the square root, 0.385, pretty darn close. We're going to do more with this. I just wanted to introduce you guys. There is a manual way to do square roots. Most people say, oh, square roots, you have to have a calculator. No, there's a manual way to get a really close approximation. Because out to the tenths place, this is accurate. Out to the hundredths place, now it starts to become a little inaccurate, but it's still only off by 2/100ths. That's really close. That's 2 cents off of, the right dollar. If you want to talk in those terms. Now, we're not done though, right? All that work and we're not done. That's my slant height. Now I got to go back to what I was actually trying to do. Yeah, the rest of it's real easy. You just got to plug and chug. So, plug and chug, like a train, like chug down the tracks. All you got to do is put things into it and make it happen. So we know our pi. We know our radius was 2 inches, and we know now our slant height, we're going to use 5.385. when I do that, I get one of the lateral areas. And when I combine both and multiply by 2, that's approximately 10. That's going to give us about 32, 60, around 65, I think. Can somebody,
No, it's 33.8.
did you double it? Because remember, we have 2 hats.
Wait, so what's the
67.648.
Hold on, 67 point.
29.
That's 67.669.
So one of you probably used actual pi, and one of you probably used 3.14.
Oh, it's actually
Okay.
5.
It says to the nearest square inch. So approximately 67, right? Can we agree on
No,
that?
actually, wait. I used actual pi.
What'd you get?
I got 67.669.
0.6. Okay, so we'll say 68. We'll round up to err on the side of caution. If you want to have too much as opposed to having too little, just always round up.
and what's the actual lateral area?
It depends if you use actual pi or 3.14. It doesn't tell me. That's why we're approximating.
So if it
Like,
doesn't tell
I
me,
will accept multiplies. On the state tests, it will tell you specifically what to use. It'll tell you either use 3.14 or use pi button or whatever. It'll tell you. So then we would know I need 68 square inches, but since we're cutting interesting shapes, we're probably going to need more paper than that actually. Any questions here? To talk about this before we get too far into things, your homework, in case you have not looked at it yet, very specifically at the beginning of the homework, says what? You can tell me. Well, okay, yes, it says read me first, and if you read me first,
It says that you don't need to turn it in and that you run it too later and
that homework will not be graded in Schoology. I mean, you can submit it. Those answers where you type it in, if you type it in exactly how it wants it, you can figure out if you got the answer right or wrong. I don't care about that, though. That's not where I'm getting your grade from. Tomorrow in class, to wrap up Chapter 13 and make sure that we're all ready for the Mastery on Friday, we are going to be doing, like, checking that together. What I need to see is your work for those problems written out on a sheet of paper with formulas showing, with the process showing. You cannot tell me tomorrow, oh, I used a calculator, I didn't write out my work. That does not fly. I will kick you out and send you to the office because obviously you don't care. We will then have a follow-up conversation about whether you should be in this class or not. You need to write your process out. As this math gets more difficult, you cannot just use a calculator. Trust me, this is not the teacher telling you, do it because I said so. This is the mathematician saying, I've been in those higher math classes. I've made those mistakes because I've tried to not write things out. You will save your time and your energy if you just write it out the first time. Are we clear? Tomorrow, I will first off be checking, did you do it? Did you write out processes, etc., etc. Then we'll go over each of those problems. In 13.5, if you go into that folder, you have to navigate into the folder. There are some Khan Academy activities posted. If you want some extra practice, feel free to go and do those Khan Academy activities. But really, 13.4, that homework where you got to write it out on paper, that's really your last like assigned homework for the chapter. Cool. Any questions on that? 13.5 stuff's optional activities in Khan Academy because it gives you instant feedback, right? That's what I like about Khan Academy. You get that whole, I got this problem right or I got this problem wrong right now. And as like this year, you guys have no idea, but I made tons of changes this year, like getting away from digits. Next year, I hope to do more with Khan Academy and even less of like my own multiple choice sort of homework things. So here, we actually have the same problem. Now you're making a TP for your little brother. We want to know how much fabric that we need. So we're going to go to Joanne Fabrics or whatever. But we want to buy the specific amount and cut it so that we don't spend any extra money, right? Because I don't want to spend extra money on my little brother. Who would want to do that? So we know it's $1.30 for 1 square foot. So square foot tells me, what am I calculating about this? Square foot tells me I want to calculate, am I talking area or volume? Square feet area, right? So We want to do the same thing again. And hopefully this makes our process really fast when we get up into these chapters, the other ones. Make a right triangle. So either on your TP or over to the side. Whatever you call it, cursive L for length, or S for slant height, or actually some people call it H sub S, the height of the slant. Some people say. Subscripts don't do anything, they just tell us details. So H sub T would maybe be the height of the TP, where H sub S is height of the slant. That's a little, this is H with a little s. So you can name it any of these things. It doesn't matter, these are just all options. So again, we want to use our Pythagorean theorem. So we're going to set up that, let's just go ahead and call it S squared will be the 4 squared plus the 6 squared. It's going to be 16 plus 36.
52.
Gives me 52. And sorry for anyone watching at home, I'm writing under my video capture thing. So if I bring this over here so people watching at home can see, we got to get S by itself. So again, inverse operations. We square root. Now, hang on. Let's try this method again. I want to see how close we can get. Ozzy, find our exact square root since you're already calculating. Hold it, not yet. What would this be between? What other perfect squares? Well, think about 5 squared, 6 squared, 7 squared, 8 squared. Where would this be between? Well, we know 6 squared was 36. 7 squared was 49. And 8 squared was 64, right? So my 52 falls in here, in between, at more than 7. How much of the gap between them has it covered? How much higher than 49 is it? 3. How big is the gap between those perfect squares?
Between.
Not 25, 15 actually. Because go 1, that gets you to 50. 14 more gets you to 65. So, this reduces. 7 1/5, which really comes out to be 7.2. Ozzy, if we calculate the actual square root, what is it?
It said, well, it didn't really give it to you. It just said 2 square root over 13.
Oh, your calculator's set to give you radical answers. That is in your mode settings.
I did change it.
So if you go to mode and you tell it to do scientific or float as opposed to radical. What are we doing? Square root of 52. There you go. So guys, if you hit mode, which is right here on your calculator, you'll see a menu that gives you like scientific, radical, whatever, float, yada yada. You want this, Ozzy's was set into math print. I changed it to classic, which is going to give you your classic, just whatever answers. As we want different types of answers, we can change our mode to spit the answer out in different ways. His was set to spit it out as a simplified radical value, which has a number multiplied by another number, like by a radical. We don't want to do those yet because we haven't talked about simplifying radicals. That's more of an 8th grade type thing. So my S here actually comes out to be, Ozzy, what'd you get as the square root? 7.2.
7.2.
1110. So hold on. So we, by our approximation method, got 7.2 without even a calculator. And our answer, when we round it, is 7.2. Square roots are not some magical thing that you have to have a calculator for. You just have to understand what we're doing. We're cutting a gap. We're placing a value on this number line of perfect squares. All we're saying is what square root value does it match to when it's between two perfect squares? So now that we know this, I again can set up my formula for lateral area of a cone, which is just pi times radius times slant height. So the radius of the base we were told was 4. My slant height is approximately 7.2. And we only have one TP. So our lateral area is going to equal 28.8 what? So if I was going to Joanne's, I'd probably buy a minimum. What do you think? How much would you buy?
30 feet.
Yeah, at least 30. So you have a little bit extra.
So we have to figure out how much it costs.
So
Then you
If-
just have to do 130 times 28.
Yeah, basically. It's like,
if we assume we're gonna buy 30, let's make this a realistic problem. Don't touch your calculator yet. If we assume we're gonna buy 30, how could I break up the 30, make the math easier, and save me from using my calculator? Who said it?
What?
What'd you say?
10 times 3.
30 can be broken into like 10 times 3, right? What if I was buying 10 square feet? What if I was buying 10 square feet?
$13.
Move your decimal, and we get $13. But if that's for 10 square feet, and I'm buying 30, just do 13 times 3, and we get that our approximate cost, if we buy a little extra, and we don't use a calculator, will be about $39, which really, guys, if we're talking real math, what are you going to tell your parents? Hey, this is going to cost about $40. So, this is not exact, hence the fact that we used the approximate equals. We use the squiggly equals to say, we're not doing pure math right now, we're doing approximate math. Any questions? Yeah.
How come when we were doing the math, we only did it on one side? Should we do it on both sides?
What do you mean?
Because when we were making the right triangle, how come we only did it on one side, not the other side?
Oh, we know it's symmetric. So to figure out the slant height, all you need is either this or this, but they'll be the same.
I know, but when you're trying to figure out the actual price, wouldn't you have to multiply by 2?
So this triangle was just a look at if I cut my pyramid straight down the middle and looked at only one side of it to figure out the length of this edge.
Oh.
But once I know that edge, I'm looking at the whole thing when I use this formula.
Alright.
This, don't think about we did it to half of it. We just pulled out the part that I needed to find the information necessary. Okay? Because when we use this formula, that's the entire around of the cone. Anish?
How come, like, when you're using ladder, how come you didn't use pi? You only multiply 4 times something, too.
We should have used pi. Did somebody forget to multiply by pi? Gentlemen? If I can't trust you to give me my calculations, guys.
It's like 90 something.
that's like when say, we should
It's like 90.
That's what I meant.
Yeah.
Guys, you gotta speak up. Have the confidence in your solving. So, would you get 90.4?
7, 8.
So, if we're gonna round to the nearest square foot, yeah, like the 7 would round the 4 up to a 5. Technically, it'd probably round down, but since we're doing math in real life, I'm gonna round it up so I have extra fabric. So, if it was like 90.4, I'm gonna say. So I'm going to round and just say 91 square feet. So then if I multiply that, well again, I could do 13, but then it'd be 13 times 9. And then a little bit more. Really, I could honestly just overbuy. And if it's 91 square feet, how many square feet could I buy?
95.
100 would make this really easy. If I just buy 100 square feet, then I'm going to spend approximately $130.
That's not 40.
That's
If I buy 100 square feet. Now, that's an upper estimate. Here's a trick. Not like a play a trick. Here's a trick to use with your parents. if you want them to be more likely to buy you something, never tell them it's cheaper than it is. Tell them it's more expensive than it is. Because when you say, I want to build a teepee, it's going to cost $130. Like $130, and when it actually costs $120 or $100, then in their brain they think they're getting a deal. And they'll be more likely to say yes, as opposed to if you say $130, like $130, and you get there and it's actually $150 because you didn't round up, you didn't overestimate, and they're like, you said it was $130, it's $150, actually we're gone. Nope, we're not doing this. Always overestimate so it's cheaper than you thought. That's a good financial trick. That's also good with your bills. Always think your bills are going to be more expensive than what they were, so you have money left over at the end of the month. I have a boatload of papers. I had to captain this boat on the way to school today.